Welcome. In this video, I will talk about static one-dimensional arrays in C++. So, what are static one-dimensional arrays? The simplest way of thinking of these arrays is just a list of items. And each item in this list has a position. These positions start at 0, so the first element in the list would have a position of 0. The second element would have a position of 1. The third element would have a position of 2, and so on and so forth. These arrays are made up of elements, as we have been discussing, and these elements are of the same data type. This data type can be a simple data type, such as an integer, a string, a float, any of those data types that we have talked about thus far, or they can be a user-defined data type, as we will talk about in the future. The arrays that we will be covering are static, thus they have a fixed size. They are static because once we set the size of them, they are not going to change. That is because this size is going to be allocated when the compiler compiles our program. So we cannot change that size because the size must be known at compile time. And if we're changing it later on in our program, that means that it's not known at compile time. And this memory that will be used for these arrays are continuous in memory. So how do we declare these static one-dimensional arrays? To do that, we must provide the compiler with 3 pieces of information. Those 3 pieces of information being the data type of the elements in the array, the name of the array, and the size of the array. And the syntax for doing these 3 things is right here. And this is how you will do it in your programs, except for you will fill these variables right here out with your own relevant information for your program. So you have a data type, and that can be any data type again. Just as we see over here, it can be any data type, simple or user-defined. And we are going to name our array. This has the same naming convention as identifiers have, so this can be any identifier. And then we're going to have an open bracket. You must include this open bracket in your own code. And then some size and a closing bracket. This size right here is a constant expression that's going to evaluate to a positive integer. And it can be any positive integer that is needed for your program. It can be a very large integer. You can make very, very large arrays if you need to. And that size is going to specify the number of elements in the array. Once you have declared a one-dimensional array, you may want to access the elements of the arrays to do something such as output the values of an element, use the values of an element in expression, or update the element. And we say values because for now, we will only have single values at our elements, such as integers or floats. But later on, we will see that you can have more values there using structs. But don't worry about any of that now. For now, it is just going to be a single value at each element of a single data type. In order to access these elements, you are going to need to use the position of the element that you want to access, the positions being starting at 0, going up to the array size -1. Why the array size -1? Because it starts at 0 instead of 1, so 0 to array size -1 will give us array size elements. So you're going to take the position of the element you want to access and place it inside of 2 square braces. And the syntax we're going to do that in our program with is we're going to say the name of our array, the identifier that we gave it over here, this identifier, and then we're going to put a open bracket and the index of the element that we want and a closing bracket. This index expression can be any expression. It's called the index, and it can be any expression whose value is a non-negative integer, so 0 or more, or 0 or greater, and it is within the range of the size of the array -1. And technically, you can use numbers past the size of the array, but you will get errors in your program, as you will see later on in a different video that are not so much fun to go back and find, unless you are programming very carefully. So make sure that this index expression is always within, that it's non-negative first off, in that it is in the vicinity of, or in the range of, the array size -1. So here's an example of declaring an array and accessing the elements of an array. Here we declare an array that holds integers, call it ARR, and we give it a size of 10, which you can see down here. We get an array with 10 elements in it. Each of those elements have an index starting at 0 and going to the size -1. In this case, that is 9. And they each have an address that is a hex number for the address. So that is why you see letters over here. And they are continuous in memory. That's why they go up by 1 hex value each time. And they don't necessarily have to be at these memory locations, and they don't have to be this short of addresses, and they won't be this short of addresses because they just aren't that short of addresses in computers. Here we can see us placing some numbers inside of this array. This line right here, ARR, at position 0, we want to set it to the number 20, which we can see down here. We get 20 placed at that memory address, which is the index 0 of our array. The 5th index of our array, we want to place the value of 7, so that gets placed there. At the 9th index of our array, which is the final index of our array, we want to place the value 99, so we get it placed right there. And we can see here that this 27 doesn't get placed anywhere in our array. Well, that is because we're going to the size of the array, which is 10, but remember the indexes only go to 9, so this is an invalid index, and it may cause a seg fault. Going 1 past probably won't cause a seg fault, but going much more past there will cause a seg fault in your program, which is a error that is not very helpful when you get it output on the screen. So anytime you see a seg fault error on your terminal, just note that probably means you're going to an invalid memory location. Well, that's definitely what it means. And in this instance, it will probably be you are going to an invalid memory location in your array, aka past the end of your array. The last thing I want to touch on before we get to an example of code is every time we declare an array, we want to make sure that we initialize the values in the array. Otherwise, we're not going to know what the values in the array are. Just like when we make any other variable, a simple variable, the value can be anything, because this memory that the array is being made of is just memory that's pulled off the heap. And this heap is just all the memory that is available to your program at that time. And the bits of that memory could be either 0 or 1 from a previous computation, because previous computations do not go back and reset every bit to 0 or every bit to 1 at the end of their computations, because that would just take way too long. So we need to fix this in our programs ourselves, and to do that, we need to set each element to an initial value, and we can do that using loops. For loops or while loops are generally what you would use. So we have an example here, and if we wanted to say keep track of multiple counts, in this example we have 10 counts that we'd be taking track of, then we want to start them all at 0 usually. So if we're counting things, we would want to start at 0 with the counts. we want to make sure every value in our array starts at 0. So here we make some array. Remember here that we have to make this variable into a constant, so it's no longer a variable, it's now a constant. And that way the compiler knows that it will be 10 and that this constant or this value can't change, so that the value is known at compile time, because the compiler must know that to allocate the correct amount of memory at compile time for your program. So we make that constant of the size, which will be 10. We make a array of size 10 here, which holds integers, and then we loop through that array, accessing all the elements. This loop will go from the 0 to 1 minus the size of the array. Why is this 1 minus without having this be size minus 1? Well, because it's going to less than, so this will go all the way up to 9, and then 9 will run, and then once this increments up to 10, it will break out of here. So this will only loop from 0 to 9, so it will loop the correct amount of times to fill this array with this initial value of 0. Let's take a look at using arrays from a program. Here we have a constant, which is called array size. We will use this throughout the program whenever we need to reference the size of our array. This is going to be equivalent to 10. Why? Or just because that is what we're going to use for this example. Remember, this has to be a constant. If you don't make it a constant, you'll get a compiler error, because the compiler has to know the size of the array to declare the proper amount of memory for the array. And then here we declare the array, and we are making it an array of integers. We are calling it ARR, and we are making it the size of 10, which is stored in this constant array size. Right here, we are initializing the array in this for loop. We are going from the 0th element in the array to the array size -1 element of the array. We are doing that by using the less than operator, the less than the array size operator, because if this I is less than the array size, then it is in bounds. That would be the array size -1, because when this goes to 10, it will break out of this for loop. So 9 is valid, 10 or above is invalid. So this will just go through, store whatever value we have for I at that position in the array. So 0 will get the value of 0, 1 will get the value of 1, 2 will get the value 2, so on and so forth. And then we come down here and we print the elements in the array, and then we output a new line, so those elements in the array are on their own line in the program. So let's come down here and go to a clean terminal window, and we can compile the program with G++ and the name of the program, and then we can run it using ./a.out, and we get the array output to the screen, which is the numbers 0 through 9, which is because from this for loop, we're again just going through and placing whatever value we have at I at that time at that element in the array. So 0 will get 0, 1 will get 1, 2 will get 2, and so on and so forth. And that's all I have for you for this video. Thank you so much for watching, and we will see you in the next video.